All right, we're in grade 9 and we are going to look at sets, but basically we will look at the set notations and the symbols that are used in this topic. Now, there are several notations that are used in sets. Let's start with this one. Let's say set M. Set M is the set of A, B, C. All right. So that is this. Now, this representation is actually common. Let's have, for instance, let's say we have set M. That's actually the set of say 2, 4, 60, 80, 10, and so on. It's infinite. Okay. Yeah, so it's easy when you come across a set like this one. But sometimes the representation could be, let's say, set N, which is a set of, say, um, uh, uh, A, such that A is a natural number. All right. So this notation now it's more or less complicated if a learner is not in line with the definition here. Okay, so this one is actually meaning that the element A, such that the element A is a natural number. So A is a variable. It varies. It keeps changing. So as long as you change this element, you must make sure that you get a natural number. So it means this set would actually be set N, which is the set of natural numbers 1, 2, 3, 4, 5, 6, and continuing like that. All right. So it comes back to this representation, but here it was in riddles. It was in riddles here. All right. Now, let's say we have set P, all right, which is a set of, let's say, element X, okay, such that A is less or equal to X, which is less or equal to, say, B. All right. This notation, it's actually comprising of an interval. So that means the element of set P should be elements X. X stands for elements. Now, those elements should be between A and B. They should start from A and end at B. Those elements, X. Right. Now, what does that mean? It means that P would be a set of A comma B. All right. So you start from A, you stop at B. But now let's say the interval had been let's say it had been like this. Say X P is the set of X such that negative say negative 4 is actually less or equal to X, which is less or equal to 1. Okay, like this. So that means here now our A is negative 4, our B is 1. But there are numbers between negative 4 and 1. So that means that P in this regard would be the set of, all right, the set of negative 4, comma, negative 3, comma, negative 2, comma, negative 1, comma, 0, comma, 1. So the elements in this set starts from negative 4 and end at 1, whereby we put other integers. Okay? Now, that means this stands for an interval. So there might have been numbers in between, but here I was just trying to break the ice and tell you that sometimes it's just A and B if we were talking about this type of elements. All right. Now that actually it's one notation, but sometimes we can have set Q, which is actually now in this form. Okay, let's say such that actually y is equal to ax squared plus bx plus c. What does this mean? Oh, it's complicated, this one, right? But it's easy. We know that this form, it's a general form for a coordinate, Cartesian coordinate, I mean. Okay. What does that mean? That means this is a coordinate that can be plotted on the axis. Two-dimensional Cartesian coordinate we would have. Okay, let me just say we have this as the x-axis, and then we have this as the y-axis. You remember that xy could be any coordinate like this. Okay, a coordinate here. All right. So this is the x Cartesian coordinate. This is the y Cartesian coordinate. Then the point, the coordinate is here, whereby we say x comma y. It's right here. That means here this set is the set of coordinates. Okay, coordinates that will produce this type of a graph. Okay, and this is a quadratic graph. All right, it's a quadratic graph. That means here set Q would be actually a set of coordinates. Let's say 2 comma negative 1 comma let's say 3 comma say negative 5, something like this. But it's just a set of coordinates, not just the numbers like this. It's coordinates. Okay. Now that means here you need to be very careful, but actually in all these are the notations, the different notations that we use in this topic. All right. Now let's continue now. Now that we have looked at the notations, we will then look at the symbols. Now the first symbol I would like us to look at is n of a. Okay, n of a. It means number of elements in set A. Number of elements in set A. Okay, number of elements in set A. Okay, so what does this mean? We will look at it later when we are dealing with examples. All right, so but all in all, you count the elements, you count them and give us that value. Okay, now we have another symbol which is actually this. Okay, set A. This one is just set A. All right, it's just set A. Okay, but we can have A like this, A union B. This is union of set A and set B, union of set A and set B. So union is all about combination. We unite the elements, we put them together, right? We have also this one, A intersect B. This is intersection. Intersection of what? Intersection of set A and set B. Okay, is an intersection of set A and set B. All right, now intersection is all about elements that appear in both sets, common elements. All right. Yeah, now we have this symbol which is a complement of set A. Complement of set A implies outside outside set A. All right. That means we are not going to we are going to list elements that are found outside set A. All right. Yeah. Now we have this special symbol, the universal set. Okay, as the universal set. So what is the universal set? The universal set is the set of all the other sets. All the other sets are found inside this set. All right. All right. We are going to look at it. Okay. Now there is this symbol or this one. Okay. So this is an empty set. This is an empty set. It's an empty set. There are no elements. That means set A is empty. It has no elements. Okay. So we'll say A equals to an empty set. Right. We have this one. Oh, how could I forget this one? This one. The main man here. An element of. An element of. So that means you have X is an element of set A. All right. This symbol means an element of. Now we have this one, which means not an element of. So if you have X is not an element of a set A, that means X is not found in set A. There is no element X in set A. All right. Let's have this quickly. Right now, we also have this one. We could see A is the subset of. Okay, let me just do this. A is the subset, right? Subset of B. Let me be clear here. Okay. So this one is a subset of. A is a subset of set B. Okay. All right. That means set A is found in set B. Okay. Now we have this one, which is the opposite. A is not a subset of B. Set A is not a subset of set B. Set A is not a subset of set B. All right. Set A is not a subset of set B. That's actually the opposite of what we were saying in the previous definition. So let me just show you what it means to say subset. One set contained in or equal to another set. Set A is contained in or equal to set B. It is contained in or equal to set B. Now, we have this one. A set A is a proper subset, all right? A proper subset of set B. Set A is a proper subset of set B. What do we mean when we say it's a proper subset? What we mean is all elements of set A are also elements of set B. All elements of set A are also elements of set B. All right? Or we could say A is not a proper subset of B. That means all elements of set A are not also elements of set B. All right? So these are set symbols which you need to grasp. Make sure that they are at your fingertips, because if you are not careful, when we get to the examples or their applications, then you will fumble. All right. So make sure that you grasp these ones. All right. So till then, when we meet in our next presentation, then we'll look at exemplary questions. All right. Take care.